Alright, number 21 for the practice exam. The level of nitrogen oxide NOx in the exhaust of cars of a particular model varies normally with mean 0.2 grams per mile and standard deviation of 0.08 grams per mile. Government regulations call for NOx emissions no higher than 0.3 grams per mile. A company has 16 cars of this model in its fleet. What is the probability that the average NOx level X bar of these cars is above 0.3 grams per mile's limit? So to describe this this distribution, my mu is 0.2, so right there, normally distributed with mu is 0.2, right? And then my standard deviation, because it is from a sample, it's 0.08, the sigma divided by the square root of n, which is the square root of 16, which is 4, right? So 0.08 divided by 4. Now let's draw out what this question is saying. It's asking what is the probability that the average NOx level of X bar of these cars is above 0.3. So my mu is 0.2 and this is my mark 0.3. So I'm looking at the right side. So I'll plug this in my z-score formula. So z is equal to 0.3 minus 0.2. Alright, let's go back. Actually, let's write the whole equation down. I don't want to miss anything. So I'm using this formula. Z is equal to X bar minus mu over sigma divided by the square root of n. So my X bar is the 0.3, my mu is 0.2, and then my sigma, remember, was 0.08 divided by the square root of 16, which was 4. That Z value, when we calculate it in the calculator, is, let's see, it is 5. So 5 is my my Z value. Now, if you remember, our table doesn't go up that high. The highest that table A goes up to is 3.49. And at 3.49, which is right here, the percentage, the corresponding percentage of that Z value is 0.9998. So if my Z is 5, what does that tell us? Does that mean that there's no corresponding percentage? No, that doesn't mean that. What that means is that, you know, if in my distribution, if right here is 3.49, then even closer to 100% is 5, right? So going back here to the question, if my z-score is 5, that means I have a number, a corresponding percentage of 0.99999999999, whatever. It's really high. So if I'm looking at the right side, I'm going to have to go 1 minus 0.0009 or 1 minus 0.999. So my corresponding percentage at the right side has to be less than 0.002 because, again, in my table, the lowest number is 0.9998. So 1 minus 0.998, if we take out our calculator, is 0.0002. That's what 2 times e to the negative 4 is saying. So if 5 is even greater corresponding percentage than 3.49, that means it's less than this 0.002. So that's why the answer for this question is letter A.